I am Radhakrishna, mathematics teacher. Today we are going to continue our indefinite integration, lecture number 7. Yesterday in the previous class we have discussed the method of integration, that is integration by parts. Now we are going to solve more questions on integration by parts today. The first question is integral cos root x dx. If it is cos x, directly it is a formula. If it is root x, what to do? If this is some x or t, then it will be integrable. So we put x is equal to t square so that the function becomes rational. Put x is equal to t square. Then differentiating on both sides, we get dx is equal to 2t into dt. Derivative of t square is 2t into dt. Then this integral will be cos t, root t square is t, so cos t into dx is 2t dt. Now it is a product of two dissimilar functions, algebraic and trigonometric. So according to our ILATE rule, we have to take t as first function, cos t as second function. We can take these two outside the integral. 2 into first function is t, second function is cos t. Now its integral is first function into integral of the second function. What is the integral of cos t? Sin t minus integral derivative of the first function. Derivative of t is 1 into integral of cos t is sin t dt. Now integral of sin t is minus cos t. So it becomes 2 into t sin t plus cos t plus c. Now substitute t is equal to root x. Then the final answer is 2 into root x sin root x plus cos root x plus c. Okay. So whenever root x is there, you put x is equal to t square and make that function rational. Next, integral x plus sin x upon 1 plus cos x. Let us simplify the denominator. 1 plus cos x is 2 cos square x by 2. Since we got the denominator in terms of x by 2, we have to write sin x as 2 sin x by 2 cos x by 2, so that it can be simplified. X plus 2 sin x by 2 cos x by 2 dx. Now separating the denominator, the first one is x by 2 cos square x by 2, we can write it as x into half secant square x by 2 plus, what is the second? 2 sin x by 2 cos x by 2 by 2 cos square x by 2, 2 cos x by 2 cancels, sin x by 2 by cos x by 2 is tan x by 2 dx. Now when you get two terms in a definite integral in which one is a product of two dissimilar functions, then you integrate only that function, that product, then automatically the second part will cancel out. Here, how to integrate x into half secant square x by 2? This is algebraic into trigonometric. So, algebraic is first function, trigonometric is second function. So, its integral is first function into integral of second function. Integral of secant square x by 2 is tan x by 2 by 1 by 2. So, integral of secant square, half secant square x by 2 will be tan x by 2. So, x into tan x by 2 minus integral derivative of the first function, derivative of x is 1 into integral of the second function is tan x by 2 dx. This is integral of this product. Write the second term as it is, integral tan x by 2 plus integral tan x by 2 dx. Now you see this tan x by 2 gets cancelled. So answer is x tan x by 2 plus c. With regard to this problem, I will give a general result. Integral x f dash x plus f of x dx. If you integrate x f dash x by parts, then automatically integral f of x cancels, then you will get the answer as x f of x plus c. If you want, you can remember this as a formula. So directly from this step only we can write the answer. Next, third question. Integral e power x into ln x plus 1 by x square. Yesterday in the previous class we have discussed the formula integral e power x into f of x plus f dash x dx is equal to e power x f x. Okay. So, let us check whether it is in this form or not. If f of x is ln x, then f dash x is 1 by x, but 1 by x square is there. Then what we do? We will change the function so that this formula can be applied. How to change the function? E power x into ln x is there. Its derivative is 1 by x. So, if plus 1 by x is there, we can directly write the integral. So, add 1 by x and subtract 1 by x. Then write the remaining term plus 1 by x square. Now, observe, this is f of x plus f dash x. We can use this formula. If you observe this and this, derivative of minus 1 by x is plus 1 by x square. So, again we can apply the same formula second time and get this integral. So, now integral of this into ln x plus 1 by x is e power x into ln x by this formula, and integral of e power x into this plus this again by the formula e power x into minus 1 by x. We can take e power x common, e power x into ln x minus 1 by x plus c. Okay. Next question. Integral ln x by 2 plus ln x whole cube. Whenever the whole function is in terms of ln x, then put ln x is equal to t. Put ln x is equal to t. But its derivative is 1 by x, derivative of ln x is 1 by x, 1 by x is not there. So, you write ln x is equal to t as x is equal to e power t, okay. Then differentiating on both sides, derivative of x is 1, 1 into dx is equal to e power t into dt. Then substituting here, integral t by 2 plus t whole cube into dx is e power t dt. Now, whenever e power t is there in the integrand, we try to write the remaining function in the form of f of t plus f dash t, so that we can apply the formula which we have discussed in the previous problem. So, we have to write this as f of t plus f dash t, e power t into, how to split it as f of x plus f dash f of t plus f dash t. Denominator is 2 plus t whole cube. In the numerator, write t as 2 plus t minus 2. Because of the denominator, we get this idea. Now, separating the denominator, you will get e power t into 2 plus t by 2 plus t whole cube is 1 by 2 plus t whole square. Next is minus 2 by 2 plus t whole cube dx. Now, if you observe, derivative of 1 by 1 plus t 2 plus t whole square is minus 2 by t plus t 2 plus t whole cube. So, this is f of t, this is f dash t. So, its integral is e power t into f of t. F of t is 1 by 2 plus t whole square. So, e power t by 2 plus t whole square plus c. Now, substitute e power t as x and t as ln x. Then x by 2 plus ln x whole square plus c. Okay. Or you can also solve by using one result. Suppose the whole function is in terms of ln x, then we can use the formula integral f of ln x plus f dash ln x dx is equal to xf of ln x plus c. Proof is very simple. If you put ln x is equal to t like this, then x will be e power t, dx is equal to e power t dt, then it becomes integral f of t plus f dash t into dx is e power t dt. It is a direct formula. Integral of e power t into f of t plus f dash t is e power t into f of t plus c, and e power t is x, t is ln x. So, if you can remember this result, we can solve it more quickly. Here f of ln x means a function of ln x, f dash ln x means derivative of f of ln x with respect to ln x. Now, by using this formula, the given question is ln x by 2 plus ln x whole cube dx. Then, since the whole function is in terms of ln x, directly we will split it as f of ln x plus f dash ln x. How? You add 2 and subtract 2 in numerator, then you can separate the denominator and write it as 2 plus ln x by 2 plus ln x whole cube is 1 by 2 plus ln x whole square minus 2 by 2 plus ln x whole cube. Now, derivative of 1 by 2 plus ln x whole square with respect to ln x is minus 2 by 2 plus ln x whole cube. So, directly this is f of ln x, this is f dash ln x. Its integral is x f of ln x, means x into this. You will get x by 2 plus ln x whole square plus c. And similarly, suppose you want integral log x whole cube. The normal method is put ln x is equal to t, whenever log x is there without base, we have to take it as natural logarithm of x. If you put log x is equal to t, its derivative is 1 by x, derivative of log x is 1 by x, which is not there. So, we write log x is equal to t as x is equal to e power t, then dx is equal to e power t dt. Then this becomes integral t cube into e power t dt. Now, we need to integrate it by parts until the power of t is completely reduced. We have to integrate it by parts 3 times, taking t cube as first function, e power t as second function. But I have already explained one shortcut method for a product of a function of the form x power n and exponential function or sine function or cosine function. What is that shortcut? You can write the first function t cube, you differentiate it as far as possible. Derivative of t cube is 3t square, derivative of 3t square is 6t, derivative of 6t is 6. Then you take the signs plus minus signs, alternate signs. Then multiply by the integrals of e power t. Integral of e power t is e power t here. Again integral of e power t is e power t. Again integral of e power t is e power t. Again its integral is e power t. You can take e power t common, e power t into t cube minus 3t square plus 6t minus 6 plus c. Substitute e power t as x and t as log x. We will get x into log x whole cube minus 3 into log x whole square plus 6 into log x minus 6 plus c. This is the answer. We can also solve it by using the formula which we have discussed just now in the previous question. without substituting log x is equal to t and without integration by parts, we will be able to write the answer very quickly by using the formula. What is that formula? Integral of f of log x plus f dash log x is x f of log x. Integral f of log x plus f dash log x dx is equal to x f of log x. Whenever the whole function is in terms of log x, you can try this method, but it is only single term. If you take log x whole cube as f of log x, then what is f dash log x? Derivative of log x whole cube with respect to log x is 3 into log x whole square. So, we add and subtract 3 log x whole square. Log x whole cube plus 3 into log x whole square, we add and subtract. This part is first two terms, we can apply this formula. Again, if you take 3 log x whole square as f of log x minus 3 log x whole square as f of log x, then f dash log x will be minus 6 log x. So, write minus 6 log x and write plus 6 log x to cancel it, plus 6 log x. Now, this plus this is f of log x plus f dash log x. Now, take 6 log x as f of log x, then what is f dash log x? Its derivative with respect to log x is 6 only. So, write plus 6, add 6 and subtract 6, that is all, dx. Now, what is the integral of this plus this? By using that formula, x into log x whole cube. Again, integral of this plus this, by that formula, x into minus 3 log x whole square, that will be minus 3x log x whole square. Again, if you take this 6 log x plus 6, same formula, you will get x into 6 log x, that is plus 6x log x. Then finally, integral of minus 6 is minus 6x plus c, that is all, this is the answer. Let us move to next question. Integral of sine of 2 ln x. Put ln x is equal to t. Its derivative is 1 by x, not there. So, write it as x is equal to e power t, then dx is equal to e power t dt, routine steps. Now, this will be integral sine 2t into dx is e power t dt. So, I will write e power t here and dt here. Now, we have a direct formula for integral of e power ax into sine bx plus c. Integral e power ax into sine bx plus c I gave, in the formula I gave bx plus c, but here it is only in the form of bx. So, I will write the result for e power ax into sine bx. What is the integral? E power ax by a square plus b square into a sin bx minus b cos bx. So, a is 1, b is 2. So, it will be e power t by a square plus b square is 1 square plus 2 square, that is 5, into a sin bx is 1 into sin 2t, that is sin 2t, minus b cos bx is 2 into cos 2t. Now, substitute e power t as x, t as ln x. It will be x by 5 x by 5 into sin 2 ln x minus 2 cos 2 ln x plus c. Okay? Or you can also solve by another method. Assume that this function is f of ln x. Then what is f dash ln x? Derivative of sin of 2 ln x with respect to ln x is cos of 2 ln x into 2. So, 2 cos 2 ln x. Let us add and subtract that. Sin of 2 ln x plus 2 cos of 2 ln x minus 2 cos 2 ln x. This plus this is f of ln x plus f dash ln x. If you take this as f of ln x, its derivative with respect to ln x is 4 sin 2 ln x. So, add 4 sin 2 ln x. Then we do not subtract because 4 sin 2 ln x is the given question only. If you now observe, this is cancelled, this plus last term becomes 5 into sin of 2 ln x. So, we have to divide by 5. Now, this plus this is f of ln x plus f dash ln x, this plus this is f of ln x plus f dash ln x into dx. So, apply the formula 1 by 5 into integral of this is x sin 2 ln x and integral of this plus this is x into minus 2 cos 2 ln x, that is minus 2x cos 2 ln x plus c. You can take x common. Okay. Let us proceed to the next question. Integral e power 2 sin inverse x. When e power some function is given, usually we substitute that function as t. Here we put sin inverse x is equal to t or 2 sin inverse x is equal to t, it is your wish. Put sin inverse x is equal to t. Then its derivative is 1 by 1 plus x square, derivative of sin inverse x is 1 by root 1 minus x square, it is not there. Then we write it as x is equal to sin t. Differentiating on both sides, dx is equal to cos t dt. Then this will be integral e power 2t into dx is cos t dt. It is in the form of our standard formula, integral e power ax into cos bx dx is e power ax by a square plus b square into a cos bx plus c a cos bx only, a cos bx plus b sin bx. This is the standard formula which we have proved in the previous class. Now a is 2, b is 1, so it will be e power 2t by 2 square plus 1 square 5 into 2 cos t plus sin t plus c. Now substitute t as sin inverse x, e power 2 sin inverse x by 5 into, if sin t is x, then what is cos t? Root 1 minus x square. So it is 2 root 1 minus x square plus sin t is x plus x, then finally plus c. So this is the integral of e power 2 sin inverse x. Next question, integral e power tan square x into sin 4x. It is a very good question. As we have discussed in the previous class, previous question, we put tan square x is equal to t. Then differentiating on both sides, we get 2 tan x into secant square x dx is equal to dt. But 2 tan x secant square x is not present in the integrand, so take it to right side, dx is equal to dt upon 2 tan x secant square x. But we should write the RHS in terms of t completely. What is tan x in terms of t? Root t. So 2 root t into secant square x is 1 plus tan square x, that is 1 plus t. Okay. Now this integral will be integral e power t into sin 4x. How to write sin 4x in terms of t? Sin 4x is 2 sin x cos x. 2 sin 2x into cos 2x. Now what is sin 2x in terms of tan square x? Sin 2x is 2 tan x by 1 plus tan square x, and cos 2x is 1 minus tan square x by 1 plus tan square x. So it will be 2 into sin 2x, 2 tan x is root t. So 2 into 2 root t by 1 plus tan square x is 1 plus t into cos 2x, 1 minus tan square x by 1 plus tan square x, that is 1 minus t by 1 plus t. into finally dx. dx is dt by 2 root t into 1 plus t. dt by 2 root t into 1 plus t. Now simplifying it, 2 root t cancels. Okay. So write this 2 outside the integral, 2 integral e power t into what is numerator 1 minus t by 1 plus t whole cube, 1 plus t, 1 plus t, 1 plus t, 1 plus t whole cube. What is the method now? Since e power t is present, we should write the remaining function in the form of f of t plus f dash t. How to write? You should get that idea how to write the numerator so that this will become f of t plus f dash t. We can write it as two minus of 1 plus t. Check, 2 minus 1, 1 minus t divided by 1 plus t whole cube. You will be getting this idea by practice. Now separating the denominator, you will get 2 integral e power t into 2 by 1 plus t whole cube minus 1 plus t cancels, you will get 1 by 1 plus t whole square. dt. Now observe it, derivative of which term is the other term? Derivative of this is not this, but derivative of this is this. Derivative of minus 1 by 1 plus t whole square will be 2 by 1 plus t whole cube. So its integral is e power t into f of t. f of t is this. We have 2 here and we have minus over here. So it will be minus 2 into e power t by 1 plus t whole square. Plus c. Now what is e power t? E power tan square x minus 2 e power tan square x by 1 plus t is 1 plus tan square x, 1 plus tan square x is secant square x whole square is secant power 4x. Then finish the next step, write it is minus 2 tan e power tan square x into 1 by secant is cos power 4x. Okay. Next question is integral x square by x sin x plus cos x whole square. Square is missing there. Integral x square by x sin x plus cos x whole square. This is totally a complicated function containing dissimilar terms, algebraic and trigonometric. Then we have to rearrange the terms so that we can apply integration by parts. Since this is a long expression compared to this, let us check what is the derivative of this. Okay. d by dx of x sin x plus cos x is derivative of x sin x is x into cos x, UV rule, x into derivative of sin x is cos x plus sin x into derivative of x is 1. So plus sin x derivative of cos x is minus sin x. Then sin x cancels, derivative of this is x cos x. If numerator is x cos x, directly we can substitute this as t and solve it. But numerator is x square, that is the problem. So what to do is, you write the numerator as x cos x, but what is the remaining, another x is there and we have multiplied by cos x. So we should write into x by cos x. Denominator is x sin x plus cos x whole square dx. Now if you take this part, we can easily integrate it by putting x sin x plus cos x is equal to t, numerator becomes dt by t square, integral dt by t square is minus 1 by t, but this is extra. Now what we do is, since we know the integral of this function, you integrate by parts by taking this as second function because integral is known and this as first function. So what will you get? First function into integral of the second, x by cos x into integral of the second. If you put x sin x plus cos x is equal to t, numerator will be dt, integral dt by t square is minus 1 by t. I am writing directly minus 1 by x sin x plus cos x, integral of this, minus integral of derivative of the first function. What is the derivative of x by cos x? U by v rule, u dash v, that is cos x minus u v dash, minus x into derivative of sin cos x is minus sin x. So this becomes plus x sin x by v square. V square means cos square x. Derivative of the first function is this into integral of the second function. It is minus 1 by x sin x plus cos x. Dx. Now we have to calculate this integral, but this x sin x plus cos x is there in the denominator also, so we cancel it. What is the remaining? Minus of minus plus 1 integral 1 by cos square x, that is integral secant square x. It is a direct formula, integral of secant square x is tan x. So write this x into minus 1 minus x by cos x into x sin x plus cos x this is plus minus into minus plus integral secant square x, that is tan x plus c, that is all. Okay. Let us proceed to the next question. Integral secant square x minus 2020 upon sin power 2020 x. Right. It is a rare question where we integrate by parts and get the answer, but as we discussed in integration by parts, usually integration by parts is applied for integrating product of two dissimilar functions, but the whole function is in trigonometric, it is containing trigonometric terms only, but we can solve it only by integration by parts. And remember one more thing, whenever there are two terms, if you separate, it is integral secant square x by sin power 2020 x dx minus integral 2020 by sin power 2020 x dx. Whenever there are two terms, no need to calculate both. You calculate the first one or sometimes second one, and most of the times the second integral will be cancelled. Okay. Let us integrate this, but we are integrating by parts, though it is not a product of dissimilar functions. For integration by parts, we have to select first function and second function, but second function should be a function whose integral is known. So, clearly secant square x is a function whose integral is tan x, it is known. So, let us integrate by parts by taking secant square x as second function and 1 by sin power 2020 as first function. So, first function 1 by sin power 2020 x into integral of the second function. What is the integral of secant square x? It is tan x, right. First function into integral of the second minus integral derivative of the first function. What is the derivative of 1 by sin power 2020 x? Derivative of 1 by t power n will be minus n by t power n plus 1. Then if we assume sin x as t, its derivative is minus 2020 by t is sin x power 2021, but we have to multiply by the inner derivative of sin x. What is the derivative of sin x? Cos x. So, into cos x. This is derivative of first function into integral of second function is tan x. So, this is the integral of this first term, and as I told you, no need to calculate the second one, write it as it is. What is it? Minus integral 2020 by sin power 2000 sin power 2020 x dx. Now observe it, here tan x is sin x by cos x. So, cos x cancels and that sin x can be cancelled from here. So, this is tan x by sin power 2020 plus minus into minus is plus integral 2020 by cos x is cancelled and 1 sin x is cancelled. So, it becomes sin power 2020 x dx, and the last term minus integral 2020 by sin power 2020 x. Now, observe it, this and this will cancel. So, answer is this plus c. Okay? But this is very rare when the whole function is containing only trigonometric terms or only algebraic terms. Okay? And applying integration by parts is a very rare case. Let us see the next question. Integral cosecant square theta into ln of cos theta plus root cosecant 2 theta. cosecant square theta into ln of cos theta plus root cos 2 theta d theta. It is a product of two dissimilar functions only. This is trigonometric, this is logarithmic of trigonometric. So, basically this is considered as logarithmic function only, this is trigonometric. So, we have to integrate by parts. What is the first function according to ILATE rule? Trigonometric is this and logarithmic. So, which is first? Logarithmic is first and trigonometric is second. So, this is first function, this is second function. Integrate by parts. First function into integral of the second, that is ln of cos theta plus root over cos 2 theta, first function, into integral of the second. Integral of cosecant square theta is minus cot theta, it is a formula, into minus cot theta. Okay. Then minus integral of derivative of the first function into integral of the second. What is the derivative of ln of cos theta plus root cos 2 theta? Derivative of log x is 1 by x. So, 1 by cos theta plus root cos 2 theta into derivative of cos theta plus root cos 2 theta, we have to multiply, into what is the derivative of cos theta? Minus sin theta plus derivative of root cos 2 theta is 1 by 2 root cos 2 theta into derivative of cos 2 theta is minus 2 sin 2 theta into minus 2 sin 2 theta. This is the derivative of the first function. Now, we have to multiply by integral of second function. What is it? Minus cot theta. So, this into minus cot theta, and we have to write d theta also. Now, the first one, minus of cot theta into ln of cos theta plus root cos 2 theta. Now, minus, observe, we can take minus common from these two, this minus and this minus will cancel, will become plus, but we have one more minus sign common. So, minus remains as it is, integral 1 by cos theta plus root cos 2 theta into, already we have taken minus sign common, cancel this 2 and take LCM there, root cos 2 theta is LCM. Okay. And from numerator we can take sin theta common, sin 2 theta is 2 sin theta cos theta. Okay. Then take sin 2 theta common, sin theta common. So, I will write into sin theta. What is the remaining? Oh, 1 minute. Here 1 by 2 root cos 2 theta into derivative of cos 2 theta is minus sin 2 sin 2 theta, it is correct. We will get root cos 2 theta plus 2 cos theta is coming into cot theta is cos theta by sin theta. Okay, d theta. Sin theta cancels. Actually, this and this should cancel out. Let us check any mistake is made. First function into integral of the second function minus derivative is 1 by cos theta plus root cos 2 theta into derivative of this is minus sin theta plus derivative of root cos 2 theta is 1 by 2 root cos 2 theta into derivative of cos 2 theta minus 2 sin 2 theta. Everything is correct only. One by cos theta plus maybe the sign or something, some error is there, we will check. Okay, if it is minus, what happens? Let us check. If it is minus, then also we are getting 2, we can't avoid 2. Some mistake is there definitely. Oh, now I identified the mistake. This is not cos cos theta. 1 minute. That is cos square theta cos. It is root over cos square theta minus sin square theta. Sin square theta. Okay, let us solve in another method, then we will be able to identify the error if there is an error. Integral cosecant square theta into ln of cos theta plus root over cos 2 theta. Okay. First I will write cos 2 theta as cos square theta minus sin square theta. Ln of cos theta plus root of cos square theta minus sin square theta d theta. Now I will take sin square theta common from the square root, or from this whole bracket I am taking sin theta common. Then integral cosecant square theta into ln of, if you take sin theta common, ln sin theta into, what will you get here? This becomes cot theta. plus this becomes root over cot square theta minus 1. D theta. Now log AB is log A plus log B. So I will write it as cosecant square theta into log sin theta d theta plus this is log sin theta plus log of this. So plus cosecant square theta into log of cot theta plus root over cosecant square cot square theta minus 1. Now I will integrate by parts separately. Here this is first function, this is second function. What is the integral? First function ln sin theta into integral of second function minus cot theta minus integral derivative of the first function, derivative of ln sin theta is 1 by sin theta into cos theta, that is cot theta. Cot theta into integral of cosecant square theta is minus cot theta. So it becomes plus cot square theta d theta. How to integrate cot square theta? You can write cosecant square theta minus 1 and integrate. Now coming to this, this is first function, logarithmic function, and the cosecant square theta is second function. So first function into integral of the second, I will write integral of second first, minus cot theta into ln of cot theta plus root cot square theta minus 1, first function into integral of the second, minus integral derivative of the first function. Here we have already discussed the formula, integral 1 by root over x square minus 1 dx is cos h inverse x. Integral 1 by root x square minus 1 is cos h inverse x, or we can write cos h inverse x as logarithm of x plus root x square minus 1. Integral of this is this means derivative of this is this, is it not? So here derivative of log of cot theta plus root over cot square theta minus 1 we want. Here assuming that cot theta is x, derivative of log of x plus root over x square minus 1 is 1 by root over x square minus 1. So it will be 1 by root over x square means cot square theta minus 1. Since we have assumed that cot theta is x, we have to multiply by the derivative of cot theta. Derivative of cot theta is minus cosecant square theta. Okay. Now this is derivative of the first function into integral of the second function is minus cot theta. Okay. This you can find, already this is over, and this is integral cosecant square theta minus 1, write the integral. Here this is you leave this, and next one is minus of minus of minus. It is minus, I need to calculate only last part, remaining part is over, write it as it is. Now this is 1 by sin square theta, this is cos theta by sin theta, and converting into cos and sin everywhere. This is 1 cos square theta by sin square theta now. So, sin theta will come up by root over cos square theta minus sin square theta into 1 by sin square theta into cos theta is cot theta is cos theta by sin theta. Sin theta cancels. Okay. And then this cos theta is the derivative of sin theta. So, write the denominator completely in terms of sin theta. It will be minus of cos theta by, you can write cos square theta as 1 minus sin square theta now. So, 1 minus 2 sin square theta into 1 by sin square theta. That is now put sin theta is equal to t. If you put sin theta is equal to t, I will calculate only that part. I will rub off everything except that part. Integral cos theta by root over 1 minus 2 sin square theta into sin square theta. Okay. Put sin theta is equal to t. Then cos theta d theta will be dt. It becomes dt by t square into root over 1 minus 2t square. Then what will you do? Take t square common. It will be dt by t cube into root over 1 by t square minus 2. Now, if you put 1 by t square minus 2 as some z, or you can put okay, z is fine. What is its derivative? Minus 2 by t cube dt is dz. So, 1 by t cube dt will be minus dz by 2, minus dz by 2 by root z. Now, you can finish it. Now, I am proceeding to the next question. Integral e power sin x into x cos cube x minus sin x upon cos square x. I will separate cos square x, e power sin x into, what we will get here, x cos x minus sin x by cos square x. Now, separate into two integrals, e power sin x into x cos x minus into dx minus e power sin x into integral e power sin x into sin x by cos square x, right. Now, as I told you in the earlier questions, when there are two terms in integration by parts, we do not calculate both, we calculate only one of them, automatically the other will cancel out. But sometimes we need to calculate both and finally we arrive at the answer. Here if you want to integrate by parts, you can observe that derivative of sin x is cos x. So if you take e power sin x into cos x, we can tell the integral without x. If sin x is t, it is e power t into dt. What is its integral? E power sin x. So we know the integral of this rounded part. So take that rounded part as second function and x as first function. Then what will you get? First function into integral of the second function, e power sin x, minus integral derivative of the first function 1 into integral of the second function e power sin x dx. Now we need to calculate this one also by parts. Minus of bracket begin. Here we take e power sin x as first function because cos x is not there, so we cannot integrate it. Take this as first function, remaining as second function. Okay. Then first function into integral of the second. Observe the second function, this is nothing but sin x by cos x is tan x, 1 by cos x is secant x. So this is secant x tan x. What is its integral? Secant x. So e power sin x into secant x minus integral derivative of the first function. Derivative of e power sin x is e power sin x into cos x into integral of the second function, that is secant x. Cos x and secant x will cancel. Now if you observe, minus integral e power sin x dx also cancels. This is minus of minus plus. This minus and plus will cancel. So I am cancelling this and this. So what is the answer? Taking e power sin x common, e power sin x into x minus secant x plus c. Okay. And I will just explain the method for next two questions. Here x square into e power x sin x is there. For integral of e power x sin x, we have a direct formula, e power ax into sin bx formula. So take x square as first function, e power x into sin x as second function and try. And this question I will explain tomorrow in the next class. So with this I am going to close the session for today. So we are going to continue tomorrow with some more problems in integration by parts and also the next method of integration, that is integration by successive reduction. Okay. Thanks for watching. We will meet tomorrow.